Good morning, everyone, and welcome to the CBCS seminar. This morning, we're going to have Allison Binley from Carleton University in Ottawa talking to us about the use of community science and data collection and the trade-offs with professional data collection as well in terms of research, conservation research, and also prioritization of funding. So I won't say any more. I'll just pass it over to you. Thanks.
Awesome. Thank you. Give me a second to get set up here. Okay. I think I'm standing in an appropriate spot there. Hi, everyone. I think I've met a fair few of you now at this point, but I'm Allison. As Rich said, I'm here visiting from Ottawa, Canada. I'm just kind of finishing my PhD. I was hoping actually to be here earlier in terms of my PhD, so I could work on some of my chapters here, but as we know, some timelines got changed there. So instead, I'm kind of wrapping things up, but I'm still really happy to be here and meet you all. And what I'm hoping with this presentation today is just, tell you what I've been working on the last few years. I'll spend like a couple minutes at the end talking about some of the work that I hope to do in the future that I'm planning on taking on. And then if anyone sees anything that's of interest to them, or you think that there's some synergies in our work, then we can have a chat later, or anything like that. So. These are my collaborators who have worked on all of these research projects with me, including my supervisor, Joe Bennett. So some of you might know Joe Bennett. No, Jonathan does. So he's based out of Carleton. He's a professor there and doing a lot of work that's probably really complementary to the work that you guys are doing here. So if you're not familiar with that, you can check out some of his research and his lab's research as well. All right, so this is the title of my thesis chapter. I did start as just a master's student and then kind of expanded this. So my research really just took me to whatever interests me. But there was this common theme that kind of came out of using community science or citizen science data, which is essentially just when we have public participation in research and monitoring. And so something that I've been noticing particularly over the last few years is this idea behind open data is really gaining a lot of traction. We talk about open data a lot, particularly in the context of making our data more open. But what I didn't hear a lot of conversations about is like going out and actually trying to use this data and recycle it, which I think is the most efficient way of doing it. And one of the more obvious available data sources that we also have is community science data. And so what I did notice, what helped me notice all this in the last few years was that during the pandemic, people really started to actually do this. I was doing it, throughout the course of my PhD, but it was really when the pandemic hit and it interrupted some of those more conventional monitoring programs that people stopped and thought, what else is already out there that I can use for my research? And to me, this is kind of backwards. Like, I think that this should be the first step, looking to see what we can use first, and then going out and collecting data afterwards, particularly given the costs. And some of my research is going to hopefully really demonstrate why that's important. I think that a lot of people have some hesitancy about using community or citizen science data based on some of these limitations, and this is totally valid. There's quite a few spatial biases present. Even if you have a more structured data set, we still experience these spatial biases. Taxonomic biases are obvious too. You'll see that all of my research that I present today is exclusively on birds. There's a lot of data on birds, and so that would make them a very good subject to study. Things like observer variability. So if we have 1,000 citizen scientists going out and collecting data, there's going to be some variation in how skilled they are, but also just their observational processes and detectability of the species. And then just pure misapplication. So when you're working with a data set that wasn't designed for the purpose explicitly that you want to use it for, you have to be really careful that it is actually an appropriate data source. But something that comes up a lot and that there is evidence for in the literature is that all of these things are also applicable to conventionally collected data. And so I don't think it's a really good excuse for not using community science data, even though working with these noisy data sets can be really challenging. In a lot of ways, we're accounting for these things in these data sets, and we aren't doing it when we use conventionally collected data. And so I find that really problematic. In addition to that, there's a lot of advantages using community science data that we don't necessarily get with conventional monitoring data. So the obvious one, me working with migratory birds, is that you cannot really use conventional methods to monitor them. I personally, as a researcher, cannot go out and appropriately monitor migratory species across their entire range because they cover too great a space, and they have these really complex dynamic life cycles as well. And so to monitor these species between, the boreal forests in Canada all the way down to South America, which is where I study them because I'm from Canada, but it's really challenging without the help of community science data. But also just referring back to that previous slide, sometimes there's stricter vetting processes too. So when we do have these spatial biases, we're actually accounting for them, or acknowledging them, and trying to develop new and novel approaches for getting around those problems, which we're not necessarily doing with the conventionally collected data. So the 3 research projects that I'm going to tell you about today, loosely these are what they are, but I'm just going to start with the first one here and we'll get down to the end eventually. Generally using community science data for population trend estimation, for looking at full annual cycle habitat associations, and also for informing decisions. So starting with the trend estimation. In North America, we have kind of this gold standard avian population monitoring program called the Breeding Bird Survey, or the BBS. And so the BBS is basically what you would usually use to monitor population trends. It's a great data set that's been collected since the 60s. So you've got long-term data, it's across North America, and they actually use volunteers to collect their data. So in a way, it is like a citizen science project, but it's organized through the government and it has a structured monitoring protocol. So they do these roadside surveys. It's very strict. They have to actually, go by those protocols. It's not like something like eBird where you can go out and collect data wherever and whenever you want. So this is really great and has been a really valuable resource over the last few years. And then in contrast to that, we have eBird, which is more flexible. Anyone can go out and do eBird checklists. I've been doing eBird checklists since I arrived the last couple of weeks, and they've been really bad because I don't know the birds here very well, but I'm trying. But this flexibility allows them to collect more data. It's noisier data, but you have more data and it's available, across the entire course of the year, whereas the Breeding Bird Survey is obviously during the breeding season, which is a very discrete period in North America. And so we've got greater variation, and also the biases are unknown, but we also have this really valuable data set that can hopefully fill some of the gaps. And so that's what I'm hoping to show with some of my research, is that we can use eBird to kind of complement the BBS in predicting how populations are changing over time. It's important to point out that I don't think it should replace the BBS. So I go on about, we don't want to do unnecessary monitoring, but I also want to explicitly state that I don't think we should be going and canceling the BBS or any of those sorts of programs because we have eBird data or anything like that. So an example I want to show you here, and again, this is just one very small snippet of the results from this project, but these are the population trends using BBS data for a nocturnal shorebird species called the American woodcock. It's not great. There's only a few squares there. I don't know if you're in the back, you might not even see where we have those estimates for. And the reason for this is because the BBS conducts its monitoring during like the dawn course. They go out in the morning and it's not the best time to be searching for a species like this. It'd be comparable to going out in the morning looking for owls, right? You might find some, and that's why we have some data here, but it's not really the best time and the most detectable that these species are. And if you compare this to eBird data, now, even if you filter eBird data to the exact same time of day as the BBS survey, just by nature of having so many more eyes on the ground and so many more people out there looking, we have a much broader range of inference, and we can actually calculate the population trends across more of the species range in this case. And so this is somewhere where the BBS really struggles, and they know and acknowledge that, and somewhere where eBird might be able to come in handy. Now, it would actually be better not to use it at the exact same time, and I would just do this for illustration purposes. But ideally, you'd want to actually monitor woodcocks during the evening hours because that's when they're the most detectable. And so this plot here, just using eBird data, I plotted the percent of checklists where you detect this species using all the data from the eBird data set. And so you can kind of see that the BBS survey window in those morning hours is basically at the worst possible time to be surveying for woodcocks. And the program's designed to be monitoring all these species, so that's totally fair and not really the BBS's fault, but we maybe don't want to be using this data source for the population trends for this species. So just for illustration purposes, I filtered the data for the exact opposite window of the BBS survey time using the eBird data. And this map over here on the right is the population trends that we get for American woodcock with the eBird data in that case. So you can see that there's actually quite a different spatial pattern in what we're seeing with the population trends. And I think this is really important. I will caveat it by saying that the credible intervals are huge. There's a lot of uncertainty with these data still because it's so noisy. And again, all I did was like a really coarse filter for this. So there's probably more fine fixes that we can put into the model, but I'm having some conversations with people at the Canadian Wildlife Service about trying to integrate other data sets like owl monitoring, nightjar monitoring data sets where we can kind of refine these. But this to me seemed like a really good example of why we would want to build a model to use eBird data when we already have something like the BBS. So yeah, in this case, we use eBird data to increase the range of the trend estimates, but also so that we could monitor these species at a more appropriate time of day and just provide more data in general. So moving on to the next chapter, what I then wanted to look at is kind of expanding on that idea of looking at, beyond just the discrete periods of the annual cycle this time instead of during the day. And so the logic behind this project was basically a lot of avian biodiversity research, things like habitat associations or the effects of certain threats or anthropogenic land uses on species is done at a discrete time of the year. So species are often studied during migration or during breeding or something like that. But these species resource needs can change quite a bit throughout the year, as well as how they're influenced by these threats. And so we really need to be looking at all of these associations in the context of the full annual cycle. And so in this case, I was interested in forest birds, like the yellow warbler seen here. And I was looking at how they associate, how strong the association with agricultural habitats is for these species. And so what we found here is looking at the full annual cycle. The y-axis here is the relative predictor importance of agriculture on these species. So how strong of a predictor agricultural land covers are on the species occurrence and distribution. In the blue here, you can see that the short distance migrants, they're quite low in the breeding season. So that's during breeding, they're actually not that influenced by agriculture one way or another. But they peak in the non-breeding season. And so there's quite a strong change in how strongly they are influenced by agricultural habitats throughout the year. And you can compare this to something like the neotropical migrants, where you can see that during migration, they have the strongest influence from agriculture, but then that they drop again in the non-breeding season, which is quite contrasting to the short distance migrants. Now that didn't really capture the direction of those relationships. And so we were also looking at how sensitive they are to these habitat types. So again, this is forest birds and how sensitive they are to agricultural cover. And we found again that the short distance migrants are more sensitive during the non-breeding period than the other periods of the year. And so they're more likely to be strongly avoiding these habitats. And so when we take these two results, the strength of the association and the sensitivity to it, the takeaway from that was that short distance migrants are more negatively affected by agriculture during the non-breeding period than at other times of the year. Now that's just one very quick result from that paper. There was quite a bit more to it, but the point that I want to leave you with today about that is just that we can't necessarily extrapolate these habitat associations across the whole year. So if you find some pattern during migration or during breeding, you can't necessarily say that that's what's going on for the rest of the year. And this obviously has some implications for conservation as well. I will say that we've only got the pattern shown here, and so we can only speculate as to the processes that are driving that pattern. Yeah, and so the third chapter of my research is actually what I had intended to come work on here with Jonathan Rhodes. It's underway and almost complete, and so I'm going to show you some of the preliminary results that we have there, which is exciting too. And so the basis behind this project is this paper came out by Robinson et al. A few years back, and they were using eBird citizen science data along with professional monitoring data to basically predict where birds would be detected. And they were using these predictions to try to inform a conservation program called Bird Returns. I don't know if people are familiar with it. It was kind of a cool, catchy project that they were doing. Essentially what they were doing is that rice farmers in California were being paid through this reverse auction process to flood their fields. And what this did was create these pop-up wetlands where the shorebirds, as they migrate through, can use as a habitat, because I think over 90% of their natural wetland habitat has been destroyed in California. And so through the Bird Returns program, which is run through the Nature Conservancy or TNC, they recreate these temporarily, but because it affects the productivity of the farmers, they have to compensate them. And so that's where the costs come in. And so Oren and his team had predicted using both professional monitoring data that was conducted by the Nature Conservancy. So they actually paid people to go out and monitor and assess where these species were actually located. But then Oren also made this predictive map using eBird data as well. And so the idea behind this project is essentially the TNC had a budget, and out of this budget had to come the money that pays for the monitoring and also the money that pays for, paying the farmers to compensate them for flooding the field. And so every dollar that is spent on monitoring comes out of the budget that's left for action. And so this might be worthwhile if the professional monitoring is really high quality and allows them to make better decisions. So the eBird, in Oren's paper, we actually found that the eBird data did a pretty good job, but because the TNC monitoring data was specifically targeted on those private lands, and sometimes it's harder for community scientists, citizen scientists to access private lands, it might have been higher quality data that just gave us better inferences about the actual places in question that we wanted to prioritize. And so my project wanted to look at whether or not we could justify this cost. So what we were doing is prioritizing farms using an R package made by Jeff Hansen and others called Prioritize R. We aimed to minimize the cost. So we wanted to do it with as least dollars as possible and maximize the predicted number of detections based on those predictive surfaces. So we did this once using the eBird data and once using the TNC data separately. When we used the TNC data, we were applying a monitoring cost penalty. So we used the real data from the TNC program as well. So I have the real bid costs, the real property locations, as well as their cost for monitoring. So everything is quite realistic there. And then we looked at a range of different budgets because we wanted to know, essentially we predicted that at the lower budgets, eBird would be useful because if the professional monitoring is taking up a greater proportion of the overall budget, obviously you're not going to have any money left for action. And so in that case, eBird would be better. But we actually thought that maybe at the higher budgets that the better quality data might result in better decisions and therefore better outcomes for biodiversity. And then we benchmarked this using kind of a golden standard approach, comparing it to an integrated predictive model that was also produced by Robinson et al. So as far as our predictions go, we found actually that at no point was professional monitoring the better option. We could use eBird data across the board. What you see here is the relative value, the difference in value rather. This is the contrasts that are shown up here. So the y-axis is the difference between eBird and TNC. And so any values that are above that dotted blue line, the 0 line, are where eBird was the preferred choice. You got better value out of eBird data. Anything that goes below that dotted line is going to be when TNC made the better choices. And then on the x-axis, we have the budgets. So as budgets increase, everything eventually hits 0 because at a certain point, it doesn't matter if you monitor it or not. If your budget is big enough, you can prioritize every single property and there's no reason to monitor at all. You just pay all the farmers and you get the max value. So there's more uncertainty associated with certain species, and this has to do with different iterations of the prioritization process, essentially just fancy bootstrapping. But the take-home message was the same for all of them. And that is that when we prioritize based on these different data sets, but also accounting for the costs associated with collecting one data set versus the other, we find that community science in this case study resulted in better conservation outcomes across the board, and there is no reason really to be using professional monitoring in this case. Yeah, so those were the 3 chapters that kind of encompass my PhD. So in summary, you could basically say that we use community science data to improve the spatial and temporal ranges at which we can do and conduct biodiversity research for conservation process or conservation research rather. But also it can help us redistribute resources from monitoring to action. So we don't necessarily have to go in with just prior information. We can use the freely available community science data to conduct our prioritizations. Therefore, we have informed action without having to sacrifice too much money. And something that I couldn't account for actually in my project is also the time. So eBird data is readily available, but you can imagine that if you wanted to set out and collect data professionally as well, that you'd have to set aside a few years of doing that first before you felt you had the information to act. So that's an important point as well. And so this last slide here is just from a publication that I have in review right now, and it's basically arguing that when we're conducting biodiversity research, particularly given the timelines that we're working with and where we're at with trying to act on biodiversity, is that we should be looking for available data first. It's not always the right action, and citizen science and community science isn't always going to be the correct data source for answering a certain question. But you'd be surprised at the amount of stuff that's out there. I've been working with count data exclusively, but there's citizen scientists collecting things like genetic data now. There's hunters and trappers that have a huge breadth of knowledge on the species that they interact with a lot. And so there's a lot of different data sources, and also just bringing it back to that open science data argument from earlier in my talk. You mean looking for other data sets that other people have applied in a certain way and seeing if you can use it for your purposes. And then moving on to see if you can integrate different data sets, or possibly you decide that then you have to go out and collect your own data because your needs can't be met. But the order of this, I think, is what's been kind of backwards for a long time, and that we can be looking for these data sources first and learning how to use them first before setting out to collect more data. Just to finish off, I'm going to plug, I'm kind of wrapping up my PhD, as I mentioned, so I'm hoping to graduate next year. That's the plan. I think it's on track so far. But I'm now working on proposing some postdoc work. So I've been talking with a bunch of the folks at eBird who have been my collaborators for some time now, especially Dr. Amanda Rodewald at eBird. She's at the Cornell lab. She's agreed to co-supervise me along with Scott Wilson at ECCC. It's Environment and Climate Change Canada. And so what I'm looking at there is other effective area-based conservation measures, which some of you might do some work with here. Essentially what I'm looking at is trying to figure out a way to optimally design new OECMs, and particularly dynamic ones. So kind of working with the idea like the bird returns program there, where we don't necessarily have to have this static protected area all year round, but if we can kind of relieve or alleviate threats at certain periods when it's most critical for biodiversity, that we might be able to have a positive impact on biodiversity that way. Currently, as far as I'm aware, OECMs, they're basically working on developing criteria and recognizing them. But I think that with a bit of a push, we could actually be creating more of them with just making some tweaks such as that. And so I've got some partners on board that we're going to try to work on developing that. And this will all be within like a decision analytic framework as well. So hoping I can have some good conversations about stuff like that here with these people. And the other thing I will plug while I'm up here is that we're organizing a value of information workshop at the end of next month. So if anyone has any interest in working on value of information or being involved in any of those projects, I would love to chat with you, and we might be able to brainstorm some stuff and get you involved with that as well. Yeah, I'm here till December. So if any of that interests you, I'd love to talk and collaborate and work with any of you. So thank you.